Welcome to clickmyproject.com. Our product title is Hard Information Bit Reliability Based Decoding Algorithm for Majority Logic Decodable Non-Binary LDBC Codes. Now we are going to discuss about our product abstracts. So in our process we are going to the modified algorithm referred to as the odd information bit reliability based decoding algorithms. In our work, the similarity is present. The algorithm updates the reliability message bit by bit in the iteration of the work, and the differential from the based on the following the process of the message. And then we are going to the full message rather than the extraneous message or passed from the variable nodes to check nodes, which can be the save or integer operations introduced by the extraneous information or computing, and thus can be the further reduce the decoding complexities. So our main objective is reduce the decoding the process and complexity also. And the variable nodes, the reliable message, the each bit within the symbol is modified to its binary singles, which is actually corresponding to bit based hard reliability. Such modification can be saved memory loads and integer operations since no soft reliability is involved. And we can check the nodes bit reliability of the extraneous informations is also changed to the hard counterpart of the hands. Thus save the integer comparison introduced by the main operations of the process. The efficient non-uniform quantization schemes is combined with the present algorithm to further reduce the memory consumptions. Now we can see our product flow diagram. In our process we can first implement the multi-core architecture. In the multi-core architecture we split the four type of architecture: addition, comparator, and subtractions and multipliers. So in our process we get the result from the multi-core architecture. We can testing process is in the testing of the core through the majority voting has been used in the previous research, but the method is used for focus on the online test and the correct pure recording the good course of the process. We already the post the manufacturing of the testing process. With the comparison we get the partial course of the process, and then the performance of the majority designs the complete the course testing process in the multi-core. And then we get the majority of the values such can shift to clock cycles. The objective of the process, it can be test multiple core and the cost of the single core process. Only one the majority values of the proposed systems we get the analyze and data get the response of the testing process. The test of the process we get the background of the information exists in parallel and outline of the concept of the process. In the architecture of the process we get the response of the comparison value. We can get the fault detections. In the fault detections of the process, the ownership of comparative and attractive solutions of the process, the classifications the method. In the first method of the increasing the number of test pins and allows the testing the multi-core process. In the second process we get the same number of the test pins used the single core and the core of the TDI pins, and the get the same time of it would be the take the same time the requirement of the many testing pins. The increase in the proportion of the number of cores. The second method of the multi-core process, it can be using the same number of the test pin would be required in the testing process. The requirement of the more number of time and the testing process will be increasing the propagation of the process number of cores. The usage of the comparator on the chip reducing the testing level of the implementation and diagrams values. The test response data multi identification cores are compared in the expectation of the data on chip and the difference of the appearance in the register values. We are getting the result under testing the fault detections. In the process we get the performance value, the same control of the function through the test control of the functions. After we get the automatically segmentation of the process Now we are going to running our product. Now we have implemented in our product silence 14.2. This is our main coding main functions. So I am going to the simulate our process. This is a simulation function. After we running the process, simulate the behavioral models, it will be running the process. After we get the I simulator, the simulator process, we can get the process result in the graphically process. Actually we give the process input, we are reset the functions, whatever we give the input and output process. I get the testing and the majority testing process. So we can implement in the subcoding of the addition and the subtractions, what are the process architectures we have designed. After this process, when will be outputted this output we get, so we are using the result reset the functions. Now we give the reset process, so zeros after running the process. So when we will give the reset the y enable, after we will give the output. So I'm going to the give the force to value for 1, it will be give the. So now I'm going to the running the process, it will be give the program process. In the process we have the fault status, it is main output of the process. After getting the testing the process, these all the process, the majority checking the process, the process all the signal of the wires process. So this is the main output of the fault detections. What are the fault is occurring in the majority codes and LTPs, some whatever the process in the store in the memory allocations. This process it will be the dash dash, so no error fault is occur not occur in the fault detections in the process. After any process like A or B or C, something like ASCII values is separated represented in the codes, it will be occur on the error in the memory allocations. After complete this process, we go into the implementation of the process. So implementation, we are going to the this implementations, we are going to the synthesis report. So synthesis report, we get the synthesis message. After we get the synthesis report in the process, what are the we are using the device summaries, design summaries process. This is a design summaries process. This is the main objective of this paper. The maximum 50% of the output is this is the result. The device utilization, what are the IC we have made the IC, this this IC, what type of the power and speed, what are the space where occurred in the process. So we are using the number of slides and number of flip flop, number of LUTs process in the simulation process. After this process, we get the input output ports of the utilizations of the number of bonds of the input output process. So this is the percentage of the process. What are the level of the percentage we have using in the process. And also we get the real and real time of the process. We have optimized the CPU times. This is a process simulation work and running process is completed. Thank you for viewing our website.